According to the National Electrical Code, it is permissible to install conductors with less than 600 volts insulation rating in an enclosure with other conductors rated 600 volts, given specific conditions are met. Article 110.3b of the NEC states that conductor insulation shall be suitable for the voltage and the application. This means that the insulation rating of a conductor must be adequate for the voltage it will carry and the environment in which it will be installed. Article 310.10 further clarifies this by stating that conductors with different insulation ratings may be installed in the same enclosure, provided that all conductors are suitable for the maximum voltage that may be present in the enclosure. This provision is crucial because it acknowledges that enclosures often house conductors carrying different voltages. To determine if a conductor with a low voltage rating is suitable, the primary consideration is the maximum voltage present in the enclosure. If the conductors with the lower voltage rating are rated for at least the maximum voltage present, their installation is permissible. For example, if an enclosure contains conductors rated at 600 volts carrying 480 volts, it is acceptable to install conductors with a voltage rating less than 600 volts, such as 300 volts rated conductors, provided these lower rated conductors are not connected to any circuit exceeding their rating and are suitable for the 480 volts present. This allowance is based on the principle that the insulation of all conductors must be capable of withstanding the highest potential difference they might encounter within the enclosure. The NEC does not explicitly prohibit the mixing of conductor insulation ratings in the same enclosure, but it sets forth requirements that effectively govern this practice. The underlying principle is safety and ensuring that all conductors are adequately insulated for the electrical environment in which they operate. Several factors must be considered when deciding whether to install conductors with different insulation ratings in the same enclosure. Firstly, the maximum voltage present in the enclosure must be clearly identified. This requires careful consideration of all circuits and equipment within the enclosure. Secondly, all conductors, regardless of their insulation rating, must be suitable for the environmental conditions within the enclosure. This includes temperature, moisture, and exposure to chemicals or other substances that could degrade the insulation. Thirdly, the conductors with lower voltage ratings must be properly identified and segregated to prevent accidental connection to circuits exceeding their rating. This may involve the use of color coding, labeling, or physical barriers. Fourthly, the installation must comply with all other applicable requirements of the NEC and any local codes or regulations. This includes requirements for conductor sizing, overcurrent protection, and grounding. The NEC provides specific requirements for conductor ampacity, which is the maximum current a conductor can carry continuously under specified conditions of use without exceeding its temperature rating. These requirements are found in Article 310 of the NEC, which includes tables that list the allowable ampacities for various types of conductors based on their insulation type, size, and installation method. The ampacity of a conductor is affected by several factors, including the ambient temperature, the number of conductors in a raceway or cable, and the presence of other heat-generating equipment. The NEC provides adjustment and correction factors to account for these factors and ensure that conductors are not overloaded. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. The NEC requires that overcurrent protection devices be sized to protect conductors in accordance with their ampacity. Article 240 of the NEC provides detailed requirements for overcurrent protection, including the types of overcurrent protection devices that are permitted, the methods for calculating the appropriate size of overcurrent protection devices, and the requirements for locating and installing overcurrent protection devices. Grounding is also essential for electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip overcurrent protection devices and prevent electrical shock hazards. The NEC requires that all electrical equipment be properly grounded in accordance with Article 250. This includes requirements for grounding electrodes, grounding conductors, and bonding. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. The NEC requires that all metal parts of an electrical system, including enclosures, raceways, and equipment, be bonded together to ensure that fault current can flow safely back to the source. In addition to the general requirements of the NEC, there may be specific requirements that apply to the installation of conductors with different insulation ratings in specific types of equipment or locations. For example, the NEC may have specific requirements for the installation of conductors in hazardous locations, such as areas where flammable gases or vapors are present. The NEC also provides specific requirements for the installation of conductors in healthcare facilities, data centers, and other critical facilities. It is important to consult the NEC in any local codes or regulations to ensure that the installation complies with all applicable requirements. In summary, while the NEC doesn't explicitly forbid mixing conductor insulation ratings within an enclosure, it mandates that all conductors must be suitable for the maximum voltage present in the application. This necessitates a careful assessment of the electrical environment, proper conductor selection, and adherence to all relevant NEC requirements to ensure safe and compliant installation. Always refer to the latest edition of the NEC and consult with a qualified electrical professional for specific guidance on your project.